welcome back to the channel. So in this video we will understand what is number system, why binary number system is used in digital electronics, different type of number system and important number system conversion. So let's begin. So now what is number system? A number system defines a set of values used to represent quantity. We use numbers in daily life for counting, measuring and computing. So humans can understand only decimal number system. Okay, but computer cannot understand decimal number system. So computer understands only binary language. So binary number system is a common way to represent any number in digital system. Okay, there are four important number system used in digital electronics. So first one is binary, second one is octal, third one is decimal, and fourth one is hexadecimal. Okay, so binary number system is having base 2, octal number system is having base 8, decimal number system have base 10, and hexadecimal number system have base 16. What is base? Base in number system, base is, which is also called radix, is the total number of unique digits used to represent numbers. Okay, so if you see, for binary number system the base is 2. It means there are two unique digits that represent this binary number system. Similarly for octal, 8 unique digits. Similarly for decimal, 10 unique digits. Same for hexadecimal, 16 unique digits. So now let's move further. So what is decimal number system? So the decimal number system is the number system we use in daily life, right? So in daily life we use 10 numbers from 0 to 9. That's why the base is 10. Okay, so 0, 1, 2 up to 9, total number count is 10. That's why the base is 10. Okay, so for example 345. So 345, how we will write the radix or base? 345 in brackets. And so now the question is, why do computer use binary instead of decimal? So decimal numbers work using electronic signals only, right? And electronic signal mainly have two states only: on, off, high, low. That's why we use binary number system which have 0 and 1. So 0 refers to low or off, 1 refers to high and on. Okay, so binary is the language of computer which use only two digits, 0 and 1. That's why the base is 2. So the binary number system, BNS, base of binary number system is 2. The unique digits in this number system are 0 and 1. Here, suppose this number 10112, each position represent a power of 2. What does it mean? So suppose my first number 1 multiply 2 to the power 0 plus second number 1 multiply 2 to the power 1 plus 0 multiply 2 to the power 2 plus last number 1 multiply 2 to the power 3. You convert this, so 2 to the power 3 is 8, plus 0 multiply anything 0, plus 2 raised to power 1 2, and then 2 to the power 0 is 1, 1 multiply 1 is 1. So what is this? 8 plus 2 plus 1, what is 11? So this is 11 in decimal number system, D N S. Okay. Generally how we represent is, so base, let's suppose the base is R. Okay. Symbols are 0, 1, 2 up to R minus 1. Okay. Suppose in binary number system, 0 to R minus 1, R means 2. In binary number system, the base is 2, so the R equals to 2. So R minus 1, 2 minus 1 is 1. So the digits are 0 and 1. Similarly for octal, R minus 1, in octal the base is 8. So 8 minus 1 is 7. So 0 to 7. Similarly for decimal, 0 to 9. And for hexadecimal, 0 to F. So let's understand hexadecimal, right? So in hexadecimal, what does it mean hexadecimal? Hexa means 6. Decimal means 10. So the total count of numbers should be 16 from 0 to F. 0 to F. So what is this F? So 0 to 9 is the basic numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 represents A in hexadecimal number system. Similarly, 11 equals to B, 12 equals to C, 13 equals to D, 14 equals to E, and 15 equals to F. So 0 to 9, 10 numbers, then 11, 12, 13, 14, 15, 16. So the total number count is 16. That's why it's hexadecimal. So maximum digits is R minus 1. In binary number system, the maximum digit is 1. Octal number system, maximum digit is 7. Decimal 9. And in hexadecimal, F. So let's understand the general formula to find an integer. Okay. Suppose X is having a set of numbers that contains x1, xn minus 2, x1, comma x0. Okay. So there are n numbers in this set. Okay. So how we will represent this x? So let's start from right hand side. So the x0 multiply r. What is the r? R is the base. Okay. Raised to power 0. So now next number is x1 multiply r raised to power 1. Similarly up to xn minus 1 into r, which is the base of number system, to the power n minus 1. Okay. So if we write in a summation form, so summation I equals to 0 up to n minus 1 x I r raised to power I. We can write this in this formula. So this is the general formula to find an integer. Okay. So let's discuss an example. Suppose let's take a previous example. Okay. So the previous example is 1011. Okay. So 101011, right? 1011 is in binary number system. So my R value is 2. So x0 is 1, x1 is 1, x2 is 0, x3 is 1. So if you put all the values in this formula, you will get answer 11. So that is my integer which is in DNS, decimal number system. Okay, so let's take another example. In a particular number system, 24 plus 17 equals to 40. Find the base of the system. So we don't know the base of the system. So he is telling in a particular number system 24 plus 17 is 40. So in decimal number system 24 plus 17 is 41, but it is 40. So we have to find in which number system that condition will be true. Okay. So let's take first 24. So 24, how we can write 24 in our number system? 4 multiply r raised to power 0 plus 2 multiply r raised to power 1. So the equation is 2r plus 4. Similarly, 17 in our number system is r raised to power multiply 7 plus r raised to power 1 multiply 1. So the equation is r plus 7. Similarly, for 40, r raised to power 0 multiply 0 plus r raised to power 1 multiply 4. So the equation is 4r. 0 multiply anything, 0. So now we can write 2r plus 4 plus r plus 7 equals to 4r. Okay. So if you sum this, 3r plus 11 equal to 4r. So if you solve this equation, r equals to 11. Let's discuss about conversions. Okay. So first is decimal to binary. Decimal number is repeatedly divided by 2 and writing the reminders after each division until a quotient 0 is obtained. Okay. So let's understand this by an example. So convert 13 into a equivalent binary number system. So how we will do this? 13 divided by 2, which is 6, and remainder is 1. So now 6 divided by 2. So I have written like decimal number is repeatedly divided by 2 and until a quotient 0 is obtained. So we have to reach up to the quotient 0. 6 divided by 2 is 3. Remainder is 0. 3 divided by 2, which is 1. Remainder is 1. 1 divided by 2, so 0. Remainder is 1. So the quotient 0 is obtained and we have received the remainders, right? So we have to write remainders in this fashion: 1, 1, 0, 1. So this is my binary number system equivalent to 13 in decimal number system. Okay. So there is one note: to convert fractional decimal to binary, multiply the number by 2. After first multiplication, integer digit of the product is the first digit binary point. Later only, fractional part of the number of the first product is multiplied by 2. A multiplication by 2 only on the fraction will continue like this until fractional part becomes 0. So let's understand this one. Okay. So let's take an example. Suppose 0.65625. You have to convert this decimal number system into binary number system. So first we have to multiply by 2. 0.65 625 multiplied by 2, which is nothing 1.31250. Okay, so my integer digit is 1. So let's again multiply this 0.31250 multiplied by 2 is 0.62500. So my integer digit is 0. Let's again multiply the fractional part by 2. 62500 multiplied by 2, which is 1.25000. So my integer digit is 1. So again multiplied the fractional part by 2.25000 multiplied by 2, which is 0.50000. My integer digit is 1. So again multiply the fractional part by 2, 5000 multiplied by 2, which is 1. So we have received our integer part 1 and fractional part is 0. So this represent 1, 0, 1, 0, 1. So the 0.10101 in binary number system is equivalent to 0.65625 in decimal number system. Okay, so now let's move further. Binary to decimal. Okay, so a binary number is converted to decimal equivalent simple by summing together the weights of the various position in the binary which contains 1. We have seen this example in the previous one. So let's see 1011. We have to convert this number in decimal number system. Okay, so let's start from the right hand side. So 1 multiply to the power 0 plus 1 multiply to the power 1 plus 0 multiply to the power 2 plus 1 multiply to the power 3. So which is 8 plus 0 plus 2 plus 1, which is 11. Okay, so one more thing, if you see at this bit is LSB, least significant bit. Why this is least significant bit? Because this is having 2 to the power 0 weight only, so which is nothing, only 1. Okay, but this is MSB. MSB is most significant bit. Why it is called as most significant bit? Because this bit is having the maximum weight in this number. So the weight is 8. Okay, so this is LSB, this is MSB. So we can write 1011 in binary number system equivalent to 11 in decimal number system. So let's move further. Octal number system has a base 8 and a method of grouping binary numbers in group of 3 bits to convert octal digit to binary by converting each digit into binary individual. Okay, so we have to convert octal number system to binary number system. So how we will convert this? So this is, we will use the method of grouping binary numbers in group of 3 bits. Okay, why 3 bits? Because in octal number system the base is 8 and in binary number system base is 2. So 2 to the power 3 is nothing, which is 8. Okay, that's why the grouping of 3 bit method we will use to convert octal to binary or binary to octal. Okay, so we will write this 472 in binary number system. 2 in binary number system is 0, 1, 0. 7 in binary number system is 1, 1, 1. 4 in binary number system is 1 0 0. So my number is 1 0 0 1 1 1 0 1 0. This is my binary number system, which is equivalent to 472 in decimal number. Oh, sorry, octal numbers. Now let's discuss about binary to octal. So in this conversion, the binary bit stream are grouped into 3 bits starting at LSB, and then each group is converted into an octal equivalent. Okay, let's start from LSB side. LSB side is right hand side. We'll group 3 bits. Okay, so 101 3 bits, then 011 3 bits, and then 01. So this is 5 in decimal number system. This is 6 in decimal number system. So 10. So we don't have the third bit for this number. So by default we'll consider 0. Okay. So 010 is nothing, which is 2 in binary number system. So the grouping of this number 265, this is equivalent to this number. So this 265 is in octal number system, which is equivalent to 10110101. So let's move further. Hexadecimal to binary. So the base for the hexadecimal number is 16. It is a method of grouping 4. Why 4? Because 2 to the power 4 is 16. Okay, so for conversion, replace each hexadecimal digit by its 4-bit binary equivalent. So the similar way we have to do in hexadecimal to binary, what we have done in octal to binary. In octal to binary, we are grouping of 3 bits, but in hexadecimal to binary, we group of 4 bit. Okay, so 2F9A. So what is A? So what is A? A equivalents to 10. So 10 is in binary number system is 1010. Okay, so 9 is 1001. F is equivalent to 15, which is equals to 1 1 1 1. 2 equals to 0 0 1 0. So let's group all together. So first A 1 0 1 0, and then 1 0 0 1, and then 1 1 1 1, and then 0 0 1 0. So this is equivalent to binary number system. So now the last one is binary to hexadecimal. Okay, so to convert the binary bit stream is grouped into pairs of 4 bit, right? So we'll start from the left hand side. So left hand side, make the group of 4 bits. Okay, this one is first group, this one is second group, and then this is the last group. So 1010, which is 10, 10 equals to A in hexadecimal. 0011, which is 3. 1011, this is 11. 11 equals to B in hexadecimal. So my number is B3A in hexadecimal. Okay. So in this video, we understood what is number system, why binary is used, different type of number system, and important conversion. In the next video, we will go deeper into binary arithmetic and digital logic concept. If you found this video helpful, like the video, subscribe to the channel and support the journey. See you in the next video. Thank you.